Shoot the target.
Here we have a character, Wesley Gibson, standing in a warehouse-type room with dimensions about 10 meters by 10 meters. There's a dead pig hanging in the center of the room with a length of about 169 centimeters, about 10 centimeters off the ground. Another character, Fox, is standing in front of the pig and her height is 170 centimeters. A target is placed 9.1 meters in front of Wesley.
You're crazy.
He then fires a bullet after making a swinging motion with his arm and whipping his gun while the bullet is exiting the Beretta 92S pistol with a 9mm bullet. The bullet then travels in a parabolic curve from the left of the pig and woman to the right after 2 seconds. The bullet passes both the woman and the pig on the right side after 3 seconds. Finally, it hits the middle of the target behind Fox and the pig after 4 seconds. Wesley whips his arm from behind him quickly and fires the bullet at Fox. The pistol is whipped in such a way that the bullet is observed curving around Fox and the pig and eventually hitting the center of the target behind them. The bullet accelerates at 4.4 times 10 to the 5th meters per second squared and has a spin from the muzzle of the barrel. The only forces acting on the bullet are gravity and air resistance. The bullet was shot out of the barrel 2.5 degrees to the right of the target, meaning that the bullet should have missed Fox and the target. There are no other forces acting upon the bullet, so there is no reason the bullet should curve. Even though the bullet has some spin on it, there is not enough to make the bullet curve so much. Also, if he fires the bullet at 2.5 degrees to the right of the target, it is impossible for the bullet to be moving in the left half of Fox's face. Also, Wesley whips his arm so fast that it is humanly impossible to do so. We calculated the ratio of slow-mo time to real time using the time in the movie it took for the bullet to hit the target and how long it actually should have taken in real life. Once we found that ratio, we figured out that he moved his arm in 0.0072 seconds. This is just a theoretical time because we do not know if they slowed down the time for the bullet to travel more than when he swings his arm. We know that this is impossible because we tried whipping our arms in that motion to find how long it took us. The gun Wesley used was a Beretta 92S pistol, which has a mass of 970 grams. We calculated this to be 9.5 newtons and added 0.5 newtons for the weight of the bullets in the pistol. So we used a 10 Newton weight and whipped our arms around as fast as we could, just the way Wesley did it, and found the average time to be 0.527 seconds. This time is much slower than how fast Wesley moved his arm, so we know that it is impossible to whip a gun that fast.